Hello, everyone. This is Heian Shin from the Center for Sustainable Development. I'm here with our Director of Education, Dr. Radhika Yengar.
Hi, everybody.
So this recording is part of our Eco Ambassador series, where one strand of the program is sharing science knowledge with students, with our community members. But the other side of it is eco-activism, where we're applying all the knowledge and the different information out there for the different actions we can take in our communities. So today we are joined by a very dynamic teacher, Mr. William Bertolotti of Plainedge High School in Long Island. So we'll just hand it over to you to introduce yourself and your students.
Hello. So I'm an advisor for a high school level research program out in North Massapequa, New York, and we're going on about 11 years. And the goal has always been for high school students to conduct advanced science research. The dream has always been that students from grade 9 conceptualize a research topic of their interests, collaborate with experts in the field, and then ultimately craft a research project that they can claim as their capstone achievement in high school. And more recently, I really worked to build up a pipeline where students aren't just conducting research for a purely academic sense, but to effectively create research that could be applied at the community level. So effectively, civic engaged science. And one major project that's really epitomized this mindset has been a microplastics project led by one of our current seniors, Spencer Feehan. And so really, his work opened up the door for future research by our underclassmen. And I really feel that Spencer's work and the work conducted by our 10th graders really epitomizes the idea of citizen science at its best. And really, much of this meeting on my end really belongs to, because it's really the hours and hours of work put on their time that made this type of research possible. So I'm just going to introduce Spencer right here. Hey, and I'm going to let Spencer take over. All right.
Hi, I'm Spencer Feehan. I'm the senior researcher on the Microplastics Pollution Project here at Plainedge High School. So basically my project, the whole project started with me finding out what the Pacific garbage patch was, which is in the middle of the Pacific Ocean. And it's really just a conglomeration of plastics and garbage and trash in the middle of the Pacific Ocean that's just been growing and growing throughout the years, and it's been recently discovered, and no one's really done much about it. So that made me think, if that's so big in the Pacific Ocean, how is that affecting me in my hometown? So I went out and thought, let me see what it's doing in my hometown. So I went to Long Beach, New York, about a 40-minute drive from my home, and I wanted to really quantify the plastics that were affecting me and the people around me. So I collected what was seemingly the easiest thing to collect, which was sand crabs. So we went each jetty along Long Beach. We did 3 different locations, and we collected crabs, about 10 crabs per site, and then we brought them back so we could really process them. So what I did was I dissected each crab. I took out the GI tract, the whole digestive system, and I digested it in 30% hydrogen peroxide, so I could get all the lipid gone, and all that was left was the microplastics for quantification. And then I put them on GF filters, so I could really just have it there, just the microplastics alone. And then with the help of Columbia and Dr. Joaquim Goes, I was really able to make this project come to life. It wouldn't have been anything without Columbia. So I went with my filters, and Columbia provided the Nile red stain so I could see the plastics and quantify the plastics under a microscope. And so I stained all my filters. I looked at them under a microscope, and then I also found out that the plastics that the samples that we collected may have been cross-contaminated by our collection process with other plastics. So I didn't want my results to be completely invalid. And I went back to Long Beach that night and collected more samples, and went back to Columbia, redissected them, reprocessed them, refiltered them, and got them all set for looking at them under the microscope without any contamination of anything in between. So we stained them again. We looked at the first samples, and there were seemingly a lot of microplastics, which was really cool to see. It was really cool to see like what it really was, but then it hit that it was scary. It was this just pollution that really took over under everyone's feet, and no one really knew. So we looked at them, we quantified them, I counted everything, I separated in between microbeads, microplastics, and microfibers. So microbeads are usually just from cosmetics, the wash-off face products. Microfibers are from like nylon shirts and polyester. Microplastics is anything else. So like a car tire, a plastic bottle, a plastic netting, anything else that broke down to the you can't see it with your naked eye, right? So we counted everything, and I brought it back to school, and I put it all in our charts, and I really read into it. And since our locations weren't too far away from each other, there was no significant difference in the amount of microplastics shown. It was just shown that there were a lot, and it was something that was completely unknown to me and unavoidable to everybody else. So that was really where my research ended. Soon I'm going to be meeting with the Long Beach board to present my findings so I can really make change in my community and not just be aware of it. And then from there, the further research is going to be taken on by the sophomores in my high school. Ryan Kanyaro is one of the lead researchers on that, so I'll let him take over from that. Ryan.
Thank you so much.
Hi. I'm Ryan Kanyaro, and so basically we saw what Spencer did, and we thought, oh yeah, that's very interesting. So what we wanted to do is we wanted to like basically expand on that, and like just go more in depth and see where like the samples are coming from. So we went and we collected samples from like the edge of the water and edge of the shoreline, and we brought them back here and isolated the plastic. And so far, we have yet to separate them and stain them so that we can take them to Columbia and analyze the samples, right? So far we've made a research paper on what we're gonna do. And to introduce that, we have Daniel Freeman.
Hello, my name is Daniel Freeman, and I really want to emphasize the reason we're doing all this research led by Ryan Kanyaro and Spencer is that we're really disgusted here at Plainedge High School by the imagery we see every day and the situation the pollution of microplastics has put on marine life and the implications it might have on human health. And so the goals of this research, and we're here to investigate the scope of the real issue, and yeah, we're really just here to solidify and make it concrete, find some concrete evidence of the real scope of the issue and make it obvious to everyone. And to follow me up, we have Jacob ZIMMERLI, who's going to talk about the history of microplastics, which is really where all the issues began.
Hello, my name is Jacob ZIMMERLI. I'm a sophomore at Plainedge High School. The idea of plastic was designed, or an idea in 1867 to replace ivory. And by 1907, Leo Baekeland managed to find a substitute for it, and it's known as Bakelite. And it really wasn't used that much up until around the 1930s and 40s when World War II began. Production of plastic increased by 300%. And by the time when the war ended in 1945, plastic was used for smaller civilian items such as bottles, parts for cars. And it really wasn't until the 1960s and 70s when red flags began to be raised, when it was shown that plastic doesn't decompose, and it was being dumped in areas, and it was releasing chemicals that affect food, and they cause cancer, and they can affect children's growth. So that's leading to modern scientists trying to find a solution to replace plastic for something more economic friendly.
Kate, you're up with an overview of the basic microplastics.
Hi, my name is Kaitlyn DiThomas, and I looked at the overview of the different types of microplastics. So there's regular microplastics, there's microfibers, and then there's microbeads. Microbeads are found in mostly skincare products, detergents, anything for personal care. Then microfibers are in shirts and fibers, and they're from polyesters and polyamides. and they usually like break down into different forms of mats and knits. So now we have Reem Hamdan and ERIN who research biohazards of microplastics.
I'm ERIN. I'm a sophomore at Plainedge High School, and two of the biohazards that I looked into are if they get embedded into soft tissue, and also, so if they get embedded into soft tissue of an organism, they can get embedded by being either ingested or they can enter through respiration. So when they do become embedded, when they accumulate, that could be very hazardous to the organisms. And also with the microplastics in the water, if bacteria continues to build on the microplastics and if they become colonies, that could become a vector for disease, either in the drinking water or people consuming the other organisms.
Hi, I'm Reem Hamdan, and to add on to like the biohazard portion, we found out that microplastics, like they accumulate POPs or POPs, persistent organic pollutants, and it's found that a lot of them can like affect biological systems. And I also researched how it affects the endocrine system, and it found out that it has a lot of EDCs, which are endocrine disrupting chemicals, and the main one found was estrogen, and we found out that smaller microplastics contain greater quantities because it leaks, like it's greater, it's more likely to absorb if it's like a smaller particle. So thank you.
So those are some of the biohazards, and next we have Matt Garcia.
Hello, I'm going to be talking about the prevalence of microplastics across the coast. So an NCAA study found that microplastics are very prevalent from national parks from Alaska to Jamaica, and that they found that microplastics are mainly arrived by streams and rivers. So we decided to go to Long Beach and to get more detail of microplastic pollution in Long Beach to decide that if there's so many in national parks across the East Coast and across the other coastlines, then there must be more in Long Beach. So we want to get greater detail on that.
And so right now, as was said earlier, the students have drafted a work in progress. And I guess that's the key, is it's both a work in progress as we've still yet to replicate the methodology, and it's also a work in progress as our hope is that these students are able to start now, right, with so much potential, begin the research process now, right, practice collaborating with each other on a multifaceted project, right? And each student has taken on a different role in the study, be it the history, be it the health risks, be it the mechanisms for distribution, and also just practicing, right? Collaborating with each other, sharing the work, working together efficiently, right? Conducting outreach to experts, right? And ultimately executing the experiment and study itself, right? And effectively, what I find so amazing about these students, and by the opportunity that you're helping to create, is that these students, they're not just high school students, they're young, aspiring scientists, and they're conducting real research that have real community applications. And so much of that's made possible just through your guidance and through all the opportunities that you've created for us. So all in all, this is incredible, and we really look forward to sharing our progress as it occurs. So thank you.
I think this is just wonderful, and thank you for sharing. We are already very, very inspired by the research that the students are doing, and as you said, it is very multifaceted. It has a health component, it has an environment, it has a science component, historical geographies, it has so many different components, and I feel that the students are in a way not just becoming scientists. I think they are becoming sustainable development managers or practitioners who can combine both science and social sciences to drive this particular change. And I like the fact that you guys are not doing just academic research, but it is leading on to a much more larger goal, or much more a goal for the social good, where you are taking the results and showcasing it at various places. Even this is a venue for us to share your amazing work with the rest of the students who are aspiring. So just one question for you, Will. has this research triggered some kind of future career perspectives for the students as they see it? Do they want to become scientists? Do they want to become, what do they want to do with this kind of research later on? Is it just going to be a class research, or are they going to continue it in the rest of the years to come?
What do you guys think? They're nodding their heads and they've got their thumbs up. This program has been going on for over a decade, and some of our alumni have gone on to careers in neuroscience, lab research. Even just shout out to Spencer, just working in Joaquim's lab, right? It seemed that he just acclimated instantly, right? And I think what's so important is, conducting research like this, through exposure alone, allows some students to realize that science research is something that, one, they can do, and two, that they like doing it. And I feel that just opening up their eyes to that realization allows them to see science as a possibility, and then to identify with science research.
One last question from me, and then Hayne can take over. What would be your suggestion for other principals and science teachers based on your experience? What would you advise them to do?
I guess I can't claim to know everything about pedagogy, but at the very least, just try, right? Be willing to run with a student's interest. Promote it however you can. Be willing to accept failure. It often happens gloriously, but always be ready to support the students, and be willing to acknowledge that in many cases, science it's more a procedure than it is an outcome, right? And so much of science is really just troubleshooting and designing a solution, right, to the task at hand, right? And that some of our best science is work that goes across years and years and years and years, right? And so in a way, it's really heartwarming to see Spencer's work being taken on by our sophomores, right? A multi-year, multifaceted science research study.
William, thank you so much. Yeah, I just want to echo the gratitude and just how amazed I am with how holistic this research has been, and the different students partaking, as you said, on hitting on the different elements of the research. My question to you, and I want to open this up to you as well as maybe the students, is either from the research part or from the actual findings on the plastics, have there been a big surprise that you have come across that you would really want the viewers to know?
So yeah, going into this project, I really didn't know like the quantity of what I was going to be looking at. I knew it was going to be a lot, and I knew it was like a pressing issue, but to really see, as going through that microscope line by line, just plastic upon plastic, just over and over again, it was really just like, it was fascinating to a degree, but it's also terrifying because it was just the magnitude of the pollution that we just let happen is unfathomable. It's not anything that I expected to be as bad as it was. And even in places that aren't Long Beach, New York, it's even worse. It's far worse. So it was just crazy to see like really how bad it was, not just reading about how bad it is.
And if you can, based on that finding, if you could kind of share the one takeaway for those who would be listening in or watching this, what would it be?
Well, it's really not hard to make like small lifestyle changes just to make a big impact. Like I don't use any plastic water bottles from my Poland Spring or anything anymore. I use a reusable water bottle. I don't use straws at restaurants anymore. I try my best to stay away from plastic utensils, forks and knives at food restaurants and stuff. It's really just like the little things that one person does that carries on with many people that would really make a big impact.
Thank you for that.
Thank you.
I think the message is very clear that it is actually a simple but very big message that, extent of the problem is a lot bigger than we just think. We, conveniently sometimes forget how huge this issue is. but it's affecting the organism at every level, every single day. All the different samples you've collected, it sounds like every single one of them has some type of a microplastic in it. And it all starts from some kind of action we could take individually, hopefully also together. But thank you so much for the work that you're doing, the research you're doing, and for your time and effort to share. We really appreciate it. Thank you so much.
Thank you. Thank you. Hey, you guys are awesome.